Okay, so trapezoids. Can anyone tell me anything about a trapezoid?
It only has one pair of congruent sides.
Not congruent. No.
Parallel.
Parallel. It has one pair of parallel sides. And it's exactly one pair of parallel sides. Okay? You cannot have two. It can only have one pair of parallel sides. So the parallel sides on this guy would be those two. We call those our bases. So this is a base. This is a base. And then the other two sides, any guesses? What do we call them in a triangle, for instance? An isosceles triangle? The legs, yeah. So this is a leg, and this is a leg. And then the angles are called base angles, but they have like a partner that they go with. So the two that are on the same base, we call base angles. And then same thing here. The two that are on the same base are base angles. Now, that doesn't matter a whole lot for just any old trapezoid, but it comes into play a lot more when you have what's called an isosceles trapezoid. And this is an isosceles. That's a really big blank, sorry. An isosceles trapezoid just means that your two legs are the same length. And so what happens with that is you end up with congruent legs giving you other things that are also congruent. Any guesses? What might be congruent here?
Opposite angles.
Not opposite angles. The base angles are congruent, okay? Which is what this theorem says. If a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent, okay? So you're looking at a trapezoid. Those are your parallels. It's isosceles. Those are congruent. That means that these two angles on the bottom are the same, and these two angles up top are the same. Okay, so you have congruent base angles. Now, the other thing to, yeah, Sebastian.
Are they supplementary?
That's the other thing I was going to say. The other thing to note is you will have those two, because we have parallel lines, right? Those two are also going to be supplementary angles. So those two will be supplementary, and these two will be supplementary, okay? It's not that the two base angles will be supplementary ever. In fact, they can't be.
Why not?
Because if they were, you'd have parallel lines here and here with right angle is the only way for them to be congruent. And what's that going to give you? 180, but it's going to give you a rectangle. So it won't be a trapezoid anymore because you'll have two pairs of parallel lines. So yeah, that you can't have your base angles be supplementary, but the consecutives that are on the same leg are always supplementary because you have parallel lines. Okay. Okay, so take a look at that first example then. It says RSTU is an isosceles trapezoid, which you can see from the markings, right? One pair of parallel lines, the legs are congruent. It says the measure of angle S is 75 degrees. What are the measures of the three remaining angles? What's angle R going to be? 75. Base angles are congruent, so 75 and 75. Can you tell me what T would be?
150.
Right, it's 180 minus that 75 because they are supplementary, right? These two are supplementary. So you get 105 degrees. And then what's the measure of angle U? 105. Keep in mind, there's another way to go about this. We know that a quadrilateral, a four-sided figure, should always add up to what? 360. So if you took away the 75 and 75, then what you're left with, being that U and T have to be congruent, you could subtract the 75 and 75 and then just cut it in half, and you would get those angles as well. So if you'd prefer to work with the sum of the interior angles being 360, that's totally fine. It's probably a little more work, but you'll get there. Okay, so let's consider, if this were not an isosceles triangle, are these two still supplementary?
Yeah.
Yes. right? The two that are on the same leg will always be supplementary because they are always same side interior angles, right? So we would say yes, because of same side interior angles. Right? If you have those parallel lines, those are going to be congruent. All right. Next example. It says, what are the values of x and y in the isosceles triangle below if DE is parallel to BC? Okay, so they're telling us the triangle is isosceles. So that means AB is congruent to AC, right? It's an isosceles triangle. AB is congruent to AC. Where do you suppose we start? What can you do with that?
The top of the triangle is isosceles, so 32, 180 minus 32, and then divide that between.
And that will be what? Not what value, what thing on our picture here? What did you just find?
Not the measure of the top triangle.
The measure of this angle right here?
Yeah, so then you can do supplementary.
Okay, yeah, so that's one way you could do it. You could find those two angles. Technically, I mean, we could prove that that triangle is also isosceles, but they told us that, well, I guess they didn't. Assuming ABC is isosceles, you also just found what angle?
Y.
Angle Y, right? So these two are actually the same thing. You could look at these two as your base angles of an isosceles triangle. So that means this is Y. So basically, this is what Evan did. Y plus 32 would have to equal 180. So 2Y is 148. Okay, then divide by 2. So Y is 74. Okay, so this is 74. This one's 74 if you want to put it in there. How do you find X? Yeah, Callie. Yeah, it's supplementary to our angle Y, right? This made an isosceles trapezoid right here. God bless you. And because these are parallel, those are same side interior angles that have to be supplementary then. So if we do 180 minus 74, we'll get the value of X, which is 106. Does that make sense? We're totally pulling in chapter 3 again here, right? Lots of chapter 3 showing up. Any questions on that? Okay, another theorem for you. That's how you know you've got a lot of theorems when we get into the 20s in a chapter. So theorem 6.20 says, if a quadrilateral is an isosceles trapezoid, then the diagonals are congruent. In other words, we can say right now that TR is congruent to US. That is only if it's an isosceles trapezoid. That doesn't have to be the case on any other trapezoid, okay? But if it's an isosceles trapezoid, TR is congruent to US, okay? So if you take a look at that picture right now, let me just point out a few things that happen here. First of all, we have parallel lines, right? So if you look at these as transversals, you also have alternate interior angles, but because it's isosceles, it's actually true that all 4 of those will be the same. So you have 2 isosceles triangles. This is an isosceles triangle on bottom, and this is an isosceles triangle on top. The other thing to notice is these 2 triangles, while they're not isosceles, they are identical. Sorry, I should have marked that with 3 because it's not the same as the leg. So you have 2 identical triangles inside, And then you have two isosceles triangles as well. So the top and the bottom, or the ones that are in contact with the bases, are isosceles. The two that are not in contact with the bases, the two that are on the legs, are identical to each other. Okay? Any questions on that? Oh no. Shoot, do you have that in the middle of your thing?
Yes.
Crap. That's unfortunate. Just ignore that. We're not doing kites yet. Apparently we're gonna have to draw one in somewhere else. Any questions on that trapezoid?
So, there's triangles on the inside and that makes those congruent triangles, correct?
These two
Yeah.
are congruent triangles. It's just been flipped, right? But they are the same triangle. Yeah. Okay. Last thing is called the triangle midsegment theorem. And we've talked about midsegments with triangles, right? Did I say triangle just now? Trapezoid midsegment theorem. Now we're going to talk about it with the trapezoid, and it's very similar, but still very different. The thing that's the very same thing is that it will all be parallel. So just like it was in a triangle, remember in a triangle when it looked like this, if you had those congruent and those congruent and you drew this in, these were parallel, right? In a triangle. The same is true when it's a trapezoid. If these sides are congruent and these sides are congruent, then all three of those lines will be parallel, okay? The other part, and this is the part that's a little bit different but feels similar still, is this. It says the length of the midsegment is half the sum. This is what's different, okay? Before, if I knew this was 18, for instance, my midsegment was just half of it, right? My midsegment was 9. Well, in a trapezoid, now there's 3 bases. Well, there's 2 bases and a midsegment that you're working with. So it's half the sum of the bases. So like if this is 8 and this is, I'm really sorry about this mess, 16, for instance, okay? Shoot, I wonder if this got all messed up too now. Basically what you're saying is half of the sum of those. So 8 plus 16, and we would cut it in half, right? So take the 2 bases, add them together, cut it in half. So 8 plus 16 is 24. Half of 24 is 12. And what you hopefully notice, the difference between these is 4 units. The difference between those is 4 units. They should be equidistant in terms of their length, okay? Questions on that? Really hope these are in the right spots now. I think they are. Okay, so let's take a look at this. And this gets a little foo-foo.
I was a little confused. Kind of like it's 8, 12, 16, so they're all little increments of 4.
Right, like you can tell that you did it correctly if the distance between the 2 numbers is the same, right? So we didn't know the 12. We did 8 plus 16 and cut it in half and we got 12. Right? The way we know we have the right number there is 8 to 12 is 4 units and 12 to 16 is 4 units. They should be the same distance away. Right? 4 units to get to the top base, 4 units to get to the bottom base.
So you got that by like dividing 16 by 2? So 16 divided by 2 is 8 and then
No.
split 8? Or like...
No. I took 8 plus 16. I took the 2 numbers I was given. I added them together, I got 24, right? 24 divided by 2 is 12. So that's how I got the 12. Then I just looked, I have 8, 12, and 16. So if I just subtract them, 12 minus 8 is 4. 16 minus 12 is 4. That's a good sign. We want that number to be the same.
I was just complicating it.
Yeah, just the difference between them. We want the difference to be the same. Okay. So now look at example 3. This is fancier, right? Now you don't just have a number, you have an expression and a number and another expression. How can you set this up to solve the problem? We said the midsegment is half of the sum of the 2 bases. Which one's the midsegment? 4x minus 10, x plus 2, or 8? x plus 2. So the mid-segment, what's is in math, equals half of the sum of the two bases. What do we do? What's the sum of the two bases? You have 4x minus 10 plus the 8. Right? That's adding together our two bases. So mid-segment is half of the sum of the two bases. Right? Is how you would set it up. Okay, so simplify that. You get x plus 2 equals half of 4x minus 2. Okay, now you have options. You could just distribute that 1/2, or you could multiply the other side by 2. I would probably just distribute here. So this is x plus 2 equals 2x minus 1. And then just keep going with the algebra. Take away the x and add the 1. And we get x equals 3. Okay, now I highly recommend that you plug this in and make sure it makes sense. So if x is 3, 3 plus 2 makes this a length of 5. Okay, so this is 8. This is 5. Without plugging anything in, can you tell me what this top one should be? It should be 2, right? Yeah.
So if you're doing 1/2 times 8, then that would be 4.
Where did I do 1/2 of 8? Oh, I simplified this first, right? 4x minus 10 plus 8 is 4x minus 2. Yeah, I mean, you could distribute it right away, but it just leaves more room for error. I would simplify it first and then distribute. Yeah. Okay, so if this is 3, 4 times 3 is 12, 12 minus 10 is in fact 2. So your numbers would be a length of 2, a length of 5, and a length of 8, which makes perfect sense because these are 3 units apart and these are 3 units apart. So it's a good way to check your answer. Yes, we have the number we're looking for. Any questions on that? Okay, I'm gonna just make one more of those up because I feel like that's always the one that throws people off. Let's see here. So these are parallel. These are congruent. Those are congruent. Let's say this is x plus 2, and this is 16. I already used 16, huh? We'll call it 22. And this is 10. Okay, so if this is your setup and we want to solve for x, how would you set that up? Remember, the mid-segment equals half the sum of the bases. What's your mid-segment? X plus 2. So x plus 2 equals what? Half of the sum of the two bases, 22 plus 10, okay? Just make sure you're adding these two together. Don't subtract them and don't ditch the 10. A lot of times because you are so used to the triangle one, people just forget about that other base. Make sure you use both of them. So this would be half of 32. So x plus 2 equals 16. There's my 16 again. Take away 2. So x would be 14. Okay. Questions on that?